Okay, now we're going to calculate molecular formula. Now, to calculate the molecular formula, you first have to find the empirical formula. Or if the empirical formula is given to you, then you just use it as is. Then once you have the empirical formula, you determine the mass, the molar mass of the empirical formula, use the molecular mass given, and divide it by the molar mass of the empirical formula. Multiply the original empirical formula by the whole number we determined in the step before. Let's try this. Let's see if I can get this thing. Okay, so it says calculate the molecular formula of a compound whose molar mass is 60 grams per mole and the empirical formula is CH4N. Okay, so since they gave us the empirical formula, here it is right here. This is my empirical formula. Okay, so what I want to do, I want to get the molar mass. So I take carbon, which is 12.01 times 1. There's only one of them there. Hydrogen, 1.00 times 4. And nitrogen is 14.01 times 1. So the molar mass of my empirical formula is going to be, let's see, 26. So 27.0, nope, 26, so 30.02, right? So that is the actual mass of this thing right here. So I take my molecular mass that's given to me, 60.0, I divide it by the 30.02, and I get a whole number of 2. So then I take that 2 and I multiply it by everything inside of here. So I get C2H8N2. This is my molecular formula. And this is my empirical formula. Let's try another one. Let's go over here and try a different one. Now we have to figure out the empirical formula. So, caffeine is made of 49.48% carbon. So I take 49.48 divided by 12.01, which is the molar mass. So I take 49.48 divided by 12.01, and I get 4.1. So basically I get 4. Whoops. Let's see. 4.11. Actually 4.12. Then I take hydrogen, which is 16. I lied. Okay, let me start this again. This is not working the way I wanted it to. Okay. So I take 49.48 grams. Let's do it this way. I feel better. 1 mole of carbon over 12.01 grams, and I get 4.12. I take 5.19 grams of hydrogen divided by 1 mole over 1.00, and I get 5.19. I have 16.48 grams of oxygen. I divide 1 mole by 16 grams, and I get 16.48 divided by 16, around 1.03. And then I take 28.8 grams of nitrogen, and I divided it 1 mole by 14.01, which is about 2, but I want to make sure it's exact. 28.8 divided by 14.01, and I get 2.06. Okay, so I'm now going to divide each of these by the lowest of these numbers, which is 1.03, 1.03, 1.03, 1.03. So 4.12 divided by 1.03, and I get 4, this one. 5.19 divided by 1.03, and I get 5, this one. Obviously this is 1, and this is going to be 2. So, let's get rid of this real quick. So my empirical formula is going to be C4H5ON2. This is my empirical formula right here. Now, let's find the molar mass of that empirical formula. So I take 12.01 times 4 plus 5 times 1, which is 5, plus 16 plus 28.01, and I get 97.05. So my molar mass is 97.05 grams. Here's the mass that's being given to me. So I take the 194.22, I divide it by 97.05. So I take 194.22 divided by 97.05, and I get 2. So I'm going to multiply this entire molecule by 2. So my molecular formula will be C8H10O2N4. This is my molecular formula, and this is my empirical formula. Okay? Let's try one more just to make sure. Okay, hydrogen peroxide is 5.93% hydrogen. So I take 5.93 divided by 1.00, which gives me 5.93. I'm getting moles here. This is moles. I have to get the empirical formula first. Then I take 94.07 divided by 16.00. So 94.07 divided by 16 gives me 5.88. 5.88 moles. Well, then I have to divide by the lowest number, which is 5.88. You can see where this is going, can't you? Basically, it is H1O1. This is the empirical formula for hydrogen peroxide. Its molar mass is 17.00. Now I have, this is my molar mass they gave me, so I take 34 and I divide it by 17. 34 divided by 17 gives me 2. It does. Gives me 2. So I multiply my empirical formula by 2 and I get H2O2. This is the molecular formula for hydrogen peroxide. Good luck, and I will talk to you tomorrow.